Hello, geometry students. Today we're going to learn to find the area of regular polygons. Remember, regular polygons are polygons that are both equilateral and equiangular. Here's our formula for the regular polygon. Remember, the apothem is a segment from the center of the regular polygon, forming a right angle with one of the sides of the regular polygon. And little p is for the perimeter, the sum of all the side lengths of the regular polygon. The easiest case is if we're given what the length of the apothem is and we're given a side. That way we can easily find the perimeter. The perimeter is the side length times how many sides you've got. And then we have A and P, and we can plug it right into our formula. And we'll know our final answer will be expressed in square units. It can be a little trickier when we're not given all that information, when we have to do a side problem just to figure out A and P. Now, if you're given one of the sides, this is the easiest situation because right away we can take that side, multiply by how many sides, and we have our perimeter. So we only really need to do one side problem to find little a. And in order to do that, so first we'll find the perimeter because that's low-hanging fruit for us. We can do that right away. Then we're going to have to draw in all of our radii, find all the missing angles, and start thinking about the situation. So before we go any further, pause the video, draw in the radii, and draw in all the angles for this regular hexagon. And then press play to continue watching. So once you've drawn in all the radii in black here, and you've got all your side lengths, we were given the side was 16. Remember that the apothem is basically an altitude of this isosceles triangle formed between the two radii and the side. That's an isosceles triangle. And so the apothem will bisect the central angle. And so we see that a 30, 60, 90 triangle is formed. And once we see that, and we remember that the apothem bisects the side, so if the side's 16, it gets cut in half, 8, 8. And we notice we have a little 30, 60, 90 triangle. The short side is across from the 30, 8. The long leg is across from the 60, and that is going to be whatever shorty is times root 3, so 8 root 3. And notice that's the length we needed to finish for our formula. And so now we have little a, 8 root 3. We have our perimeter, 96. And so we can plug it right into the formula. You're welcome to leave the answer in roots, but of course it makes more sense with area to get a decimal approximation. So the next kind of problem you can be given is if you're told the radius. This can be the most challenging because in this case, we don't even know a side length. So we need to do a side problem to figure out what the side length is, and then we multiply it by how many sides to get the perimeter. And we need to do a side problem to find little a. And so right away, the first thing we have to do is draw in our radii, drop in apothem, and find all those angles. So pause the video and draw that on your own paper and then press play to continue. Once you draw in here I've done radii in red and I dropped the apothem in blue. Notice you have a 30, 60, 90 triangle, but it's a different orientation than we saw with the regular hexagon. If you blow that 30, 60, 90 triangle up, you see we were given the radius is 2. We know radius is double whatever the short leg is, so half of that would be 1. We know to get the length of the long leg, it's whatever the short guy is times root 3, 1 times root 3, or just root 3. Now remember, this represented half a side, so we have to double it to get a whole side, or 2 root 3. And then we multiply that by how many sides? 3 sides in this case. 3 times 2 root 3 is 6 root 3. That's our perimeter. So now we have little a, we have p, and we can plug it right into our formula to get our final answer in square units, the area of the original triangle. So now you try, pause and find the area of this regular hexagon. Okay, we're given the apothem, so we have little a, but we're going to need to do a side problem to find what the side length is. And then once we know what one side is, we can multiply it by 6 sides to get the perimeter. Then we'll have A, we'll have P, we can plug and chug it into our formula. In order to do that work, we have to draw in all the radii and we have to drop down the epithem. And we see that once we do that, we have a 30, 60, 90 triangle, and we can remember that pattern to find the missing information. We're given that the epithem, we were given in the original problem that is 4 root 3. And when we add in all our central angles and all our special angles here, we see that that's the long leg of the 30, 60, 90 triangle. Therefore, working backwards to find out what the short leg is, that would be, we would divide by root 3 or get 4. Remember, that represents half a side. So one full side is double that, or 8. So now we know each side is 8. We have 6 sides, so our perimeter is 6 times 8, or 48. Now we have A, we have P, and we can plug them both into our formula to find the area of this regular hexagon. Now, sometimes you don't have the good fortune of having it happily form into a 30, 60, 90 triangle. We see the 30, 60, 90 triangle patterns in regular hexagons and regular triangles. In other cases, you have to use trigonometry to find the missing links. So here's an example of that. In this case, we're given a nonagon, a 9-sided regular polygon, and we're told that one side is 10 units long. In that case, if we're given a side length, we can easily take the side length, multiply by how many sides, and get the perimeter right away. But we cannot easily find little a, the epithem. The only way to do it is we have to pause, we have to draw in all the radii and find all those angles. So pause the video, find all those, draw this nonagon, find the angles on your own paper, draw the radii, and then press play to continue. When you draw in all the radii here in black and you drop down the epithem, I've done it in red, you can find the central angle, 360 divided by 9 is 40. When you drop the epithem, that gets bisected, so this angle is 20. And you know that these two angles in this right triangle are complementary, so this angle is 70. And only thing we were told is that a side length is 10. We know that when you drop down the altitude from the vertex angle of an isosceles triangle, that angle gets bisected and the side gets perpendicularly bisected. So we know that if the side is 10, each of these chunks is 5. And so now we go into that right triangle and we're going to use trigonometry to find little a. And we know that in this case, I did it from 70 degrees. You can do it from either angle, but I chose 70. So from 70, the tangent of 70 is opposite over adjacent, or a over 5. And to solve for a, I have to multiply both sides by 5 to get my value for little a. And notice that even though that looks funky, it's just a number, and I can plug that right into my formula. Half AP, where this is A. And then I can let my calculator round it for me to get the final area. So now you try using trigonometry to find your missing parts. And then press play for the solution. Notice you're given a side length, so right away you can find the perimeter, and then you can draw in your radii and use trigonometry to find your epithem. Once you find that, you can plug everything into your formula to get the area. And I will leave you with this picture of Cheez-It and wish you a wonderful day.